Hi, I just wanted to go over the quadratic graphing worksheet with you. So I'm going to share my screen and we'll go from there. Okay, so pretty much there are a few things to know, and these are the vocabulary terms that are important. Okay, so the standard form for a quadratic function is this right here. It's the ax, oops, the ax squared plus bx plus c. Okay, so that's the standard form. Okay, so the shape of a quadratic equation, okay, is called a parabola. All right, so it's like this U-shaped form. Okay, and when you have this point right here, this is called the lowest point is called the vertex. Okay, and to be more specific, all right, if it's pointing up, okay, if the parabola is pointing up, the vertex can also be called the minimum. Okay, and then if the vertex is pointing down, right, this is called the maximum. Okay, again, it makes sense because this is the lowest point, right, a parabola could be, so that's why it's called the minimum. Okay, so that's the lowest, and then this is the highest point a parabola could be in this situation, right, so that's why they call it the maximum. Okay, the dotted line that goes down the middle is called the axis of symmetry. Okay, so that's kind of like it cuts the parabola in half. All right, and so if you were to fold, let's say you were to draw a parabola and you were to fold it in half, that you would fold it along that axis of symmetry. Okay, all right, and solutions right here. Okay, so the solutions, this is very important because in a parabola or in a quadratic equation, all right, and if x is to the second power, okay, wherever the graph hits the x-axis, that is the solution, okay, to the, those are the solutions that you're looking for. Okay, so the x-intercepts, they could call them zeros as well, so those are all the same thing. Okay, they're all synonymous. So here and here are the solutions to the equation or to the problem. Okay, so our solutions are the x-intercepts or zeros. Okay, solutions to the quadratic equations are called our solutions are the x-intercepts. Okay, and then they're also called zeros, or they can also be called zeros or roots. Okay, so again, wherever the parabola hits the x-axis, those are the solutions, those are the zeros, those are the roots. They're all the same thing. Okay, so they say find the roots of this quadratic equation. You're trying to find where the x-intercepts are. Okay, determine so whether the quadratic equation functions have two real roots, one real root, no real roots. Okay, and so what you're trying to do for numbers 9, 10, and 11, you're trying to find where the parabola hits the x-axis. And if it does, and you have to tell us whether it does or it doesn't. If it doesn't, then you're not going to have any roots. You're not going to have any solutions. If it does, then you're going to find out where the parabola hits the x-axis. Okay. All right. And let me do one problem for you, and hopefully you'll be able to get the other ones. Let's do number 13 or actually let's do number 14. So that way we can, then that way you could pretty much answer the rest of the questions. Okay. So we have y equals negative x squared minus 4x plus 5. Let me, so negative x. So what we have to do is we have to identify the zeros, and so the zeros or the roots. So remember that in order for you to do that, you have to use the quadratic formula. You could also factor. You could also do the completing the square. All right. And so what I'm going to do is I'm going to, first of all, I'm going to use the quadratic equation or quadratic formula. So it's a equals -1, b is equal to -4, c is equal to 5. Okay, I'm going to plug it into the quadratic formula. It'll be negative b plus or minus square root of b squared minus 4ac all over 2a. You're going to plug these numbers in. Okay, so it would be negative 4, okay, plus or minus square root of b squared, which is negative 4 squared, minus 4, 8 times a, which is negative 1, times c, which is 5, all over 2 times negative 1. Okay? When you solve this out, it's going to be 4 plus or minus, this is 16, and it becomes a plus 20, so it becomes 36. Right, because this is 16, and this is negative 1 because there's a plus, and 4 times 5 is 20, so 20 plus 16 is 36, all over negative 2. So you answer this, so it would be what, 4 plus or minus, so 4 plus square root of 36 is 6 over negative 2, and 4 minus 6 over negative 2. So this would be 10 over negative 2, which is 5, negative 5, and negative 2 over negative 2, which is 1. So negative 5 is 1, 2, 3, 4, 5 is right here, and then 1 is right here. Okay, so that's where the parabola is going to hit the x-axis. All right. Now what we have to do is we have to find the vertex, right? Where it, in this case, because the a is negative, we know that it's going to be pointing down, right? And so this is going to have a maximum and not a minimum, because again, the vertex is going to be the highest point. And what you want to do is, you could either do it one of two ways, but you could either find the midpoint of these two, okay? Or you could use the x equals negative b over 2a. Okay, and so this was learned, I'm hoping that this is a good review from last semester, and I'm hoping that you remember some of this stuff. So x equals negative and then negative 4. Sorry, I'm writing on this worksheet, but I know it could be kind of confusing. Let me know if you need me to do this again. And then 2a is 2 times negative 1. So x is equal to 4 over negative 2. X is equal to negative 2. Okay, then we're going to plug in negative 2 in for this so that we can find the vertex. Okay, and notice that negative 2 is in between these 2 points. All right, so y is equal to negative and then negative 2 squared minus 4 times minus 4 times negative 2 plus 5. Okay, so first of all, by the way, we have to write negative 5 here and 1. So plug this in here. This is what? 4, and this times this negative is negative 4. Negative 4 plus 8, right? Negative 4 plus 8 is, negative 4 plus 8 is 4. 4 plus 5 is 9. So 2, negative 2 and 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It would be like right here. Okay, so the vertex is negative 2 and 9. Okay. The axis of symmetry is, remember the linear equation, it's that line that goes directly down the middle here. So here is the parabola. And this line, this is the axis of symmetry, right? And the axis of symmetry is where x is equal to negative 2. Okay. All right, so just get the x value of the vertex, and then that's the axis of symmetry. All right. What's the y-intercept? The y-intercept is where the line hits the y-axis. It looks like it hits the y-axis around the 3, okay, but, it's around the 5, sorry, the 5. Okay, but what we're going to do is, to find the y-intercept, you have to make x equal to 0. You plug in x in for this equation, it'd be 0 squared minus 4 times 0, that's 0, 0 plus 5. So the y-intercept would be 0 0, and 5. Okay. What are the domain and range? Remember, the domain is all the possible x values. And notice that in the parabola, the parabola continues to widen. Okay, it doesn't stop. So then this is all real numbers. The range is all the possible y values. Well, notice here that this is the maximum. This is the highest point. It's not going to go anywhere past this. And this is what, positive 9? So the range is all real numbers. Sorry, real numbers less than 9. Okay, I can't, sorry, a lot of it is not coming out. Okay, so hopefully that helps. Hopefully you understand that a little bit more and you're able to, don't worry about the factor or critical values part. You could cross that out. That's not really that important. Okay, let me know if you have anything else. Thanks.